Hello YouTube, XCT here. This time we are solving Crossfit2, a 50-point OpenBSD machine on HackTheBox. This box is truly not easy and involves a lot of steps. First there's a SQL injection that allows us to read files, and we use this to extract some keys from the running Unbound DNS server, which we can then use to push our own DNS updates remotely. This essentially allows us to perform a DNS rebinding attack on a password reset feature. We will use this to lure a user to a cross-site scripting payload that we host that will then connect to an internal chat system and listen for private chat messages, which will eventually give us a password we can use for SSH. For root, we will put a malicious npm module in the path of a Node.js application and then use a privileged file read to extract an SSH key and some files related to Yubikeys. So as always, we start with a port scan, and we can see that there's SSH and some website on port 80. So let's have a look at the website. Okay, again, some kind of gym website. And one thing we see in burp here is a request to gym.crossfit.htb, which I've already added to my hosts file. And this one is pretty interesting. So let's have a look at that. And here we can see that this is actually request for a WebSocket. And if we go to WebSocket history, we can see that there's actually a request being made from the server to the client. And if we reload this page, and here at the bottom, we will have the actual chat window. It's a bit elusive, so if you don't see it, just reload the page. And here we can interact with some kind of bot. A few commands we can issue here, like coaches, classes. What was the third one? Memberships. And for memberships, we can actually click on one of the items here. And the last one is a available request, which basically takes the course ID as a parameter, I think. Yeah. So let's look around a bit more. Maybe find something else that's interesting. Doesn't really look like it, right? There's this membership area, maybe this. Here we can see another subdomain, which I already added to my hosts file as well. And here we have an internal page where we can log in, but we don't have credentials, so that won't help us. Maybe we can do a password reset here. And we don't know a valid email address either, so we can't really progress here. So let's play a bit with the WebSocket request. Let's go to the main page again, refresh it. Now the chat window appears, and let's go to memberships and intercept the request. You can see the first one just put 1 here, the second one will put 2, 3, 4, and so on. So let's just increase it to something that doesn't exist, like 99. And it's telling us this membership plan is unavailable, right? So let's try it again. But this time we will try to inject some SQL here. So let's say or 2 equals 2. And let's see if that works. And here we can see that this is indeed a valid payload for a SQL injection. As the result is now no longer sorry, blah, blah. It's available, right? All right, so we know there's a SQL injection here. But this is not so easy to exploit, right? Because we can't really directly point SQL map at this. What we have to do instead is we have to create some sort of proxy application that will act as a web server. So SQL map has a normal web endpoint, and this web application will in turn then use whatever it gets from SQL map to pass it on to the WebSocket. So that's our plan of attack right now. So we don't have to write this proxy ourselves. There are a couple ones on the internet, and one of them is in this excellent blog post by Rayhan. And if you scroll down a bit, he has some code here. So I just copied it. I modified some things here. First of all, I gave it a correct endpoint, and then also in the first message, there will be a token which we extract here, and then we put it into the actual payload with the available message and our injection point here in params. So let's run that. Now we have the web server listening on localhost, expecting this ID parameter, and we can use SQL map to try to exploit the SQL injection like that. Let's see what it comes up with. And we can see it already found an injection point, Boolean-based blind injection. And here we go. It worked and we got the MySQL version. So one thing I noticed is that if we were just to use SQL map like that, like in the last request, we wouldn't get all the tables. There's some kind of error when you use the union-based injection. So what we're going to do now is we're going to force it to use the blind injection. And this way it will be a bit more reliable on the output. Okay, let's stop this here. We got the most important bits here. We got the three databases, CrossFit, employees, and the information schema. And we also know there is membership plans in CrossFit and employees and password reset in the employees database. So let's try this slower technique again to dump the employees table. I'm just going to stop that here because we got everything we will need in the end and it will just take forever. So we got username, password and email. So that's the email address, that's the password hash, but we can't really crack it. But we're going to keep that in mind because we will need it later on. So now that we got a user, we can start to explore that file role a bit more we have in the database. So let's just try to read the etc passwd file with SQL map. And that works surprisingly well. And we will be able to just read it here. So this is the file from the box. So now we know that we can read files, but not necessarily what to read, right? And in the beginning, we actually missed a port and a port scan. So let's use mask scan here. I could also use nmap, but when I tried it before, it took like 2 hours to scan the whole box on all ports, and that's just TCP. So I'm going with mask scan now. And here we go. There's one new port we haven't seen before, and this is this one. So if you throw that into Google, you will see that this is the default port used by Unbound, which is a DNS server. So what we should do now is just use SQL map again to read the configuration of Unbound, just like that. Let's read the file. And here we got some interesting options. You can see that this Unbound server is remote controllable and it's using authentication based on keys and certificates, and we can see the configured files here. So what we can do, we can read all these files, install a local Unbound server, and then try to talk to the remote one. And that's exactly what I'm doing now. Just going to paste it here. All the SQL map commands to download all the 4 files we saw there. One is actually failing, but we don't need that one, so it's not that bad. And then you just apt install Unbound. Already done it here, so it's not really required. And you copy all these files to the default location, which is an etc Unbound. Just replace all of these, right? And then you can use sudo unbound control, give it the remote IP. This one is actually wrong. Let's ping CrossFit, take the IP here. And now we can actually talk to the Unbound server on the box. So the question remains what we actually want to do with this DNS server. So imagine we could forward some domains to us. That would be pretty good, right? If something on the box would resolve a domain and that would resolve to our box, we could maybe serve some arbitrary page. But we don't really know if the box is automatically browsing any pages. But if we go to the website and especially to this employees page here, there's this password reset feature. And we got an email earlier, which is David Palmer. So we can just copy that here. And when we can ask for a password reset. and what will actually happen in the background, and you don't know that at this point for sure, but let me just tell you. This email is delivered to some bot, and this bot is clicking a link in the email. And the way this URL in the email is constructed is it's using the domain name we specified here, basically the host header, to construct the URL. So if you could put something here like X employees, and it would be valid for the password reset, then the link in the email would also go to X employees, and we could set a forward that this domain is resolved by our own DNS server. But we don't know that if we add something here, it will still resolve to this employees page, because it's a virtual host, and if you change it, usually it doesn't resolve anymore to the same one. So there's one more piece of the puzzle missing, and this is the relay D configuration of the box. So we're going to get the relay D configuration file here. That failed because the proxy is no longer running. Let's do that again. Here we go. Let's read this config file. And there are some interesting things here. Yeah, right at the top here. Requests that have the host header wildcard and then CrossFit-club. That's a new domain. We don't know that one yet. But also star employees.crossfit.hdb. So that theoretical scenario will indeed work, because everything ending in employees.crossfit.hdb will be forwarded to the correct web app, even though it starts with something different. And the way this plays out is we can add a forward here, like that. And what this will do is all requests that go to xemployees.crossfit.hdb will be forwarded to us. And because the server has some reset thing going on, we will be doing this in a loop. So now it's constantly setting this forward entry. Let me split this again. We'll need some space here. So now there's one more thing missing. It's now forwarding the DNS request to us, but we don't have a DNS server running that would answer the requests, right? So we have to do something in that regard. And what I've been using is this fake DNS server here in this repository, which has a few nice extra features we will need later on. So let's clone that. Now we have to copy the example config into new config, and let's edit that one. Actually, we don't need anything in here. We wouldn't have to copy it. And now for the entry, we want to resolve an A record for xemployees.crossfit.hdb, and we want to resolve it to our IP address, like that. So in order to run this, we do -3 factdns-c for the config file, and just run it. So let's actually find that request here, the password reset request, send it to the repeater, and now we can change the host header. Just put an X in front here and send it again. Let's see if that worked. And now we got an error. Only local hosts are allowed. We can redirect it to our box, but actually it's complaining that it wants to send it to local hosts, so there's some kind of check. And you can see that this Unbound server is doing some resetting here where it's not available, which is sometimes fucking up the tries you do. So keep that in mind. Try that again. And you can see that we actually got a request, but it's responding with the IP we configured, but yeah, it's saying it wants localhost there. And this is where things get interesting, because now we have to exploit a concept called DNS Rebinding, and this fake DNS pie is actually able to exploit it. What we're going to do is we're going to tell it that we want to actually respond with localhost, because we saw that the page really wants it to be localhost. And then we tell it after 2 requests, and you see that by just observing the box. After 2 requests, you want to respond with a different IP address, which is my own. So the first 2 requests will be localhost, and the next one will resolve to my IP address. And what this is achieving is that the password reset feature will be okay. It will find localhost, it does its two requests to do its work, and basically place the email with the user. And then the third request will be the user clicking the link, and he will get another DNS response, which is the address of my box. And there's actually one more important detail here, which is we need to add this +i here to actually forward it correctly to us. So let's run that. We have the fake DNS running. We have our server running. Let's try to do this password reset. Scroll a bit down, and it's now saying reset link sent, but we got the request. So this is working. The password reset at least is. And we got two requests, and the next one should be answered differently, not with localhost, but with our IP. And hopefully then we get some requests to our box. So this looks good. This seems to have worked. We get actually this hit by this bot, right? This bot is opening the link and it's giving us a password reset and even a token here. Maybe we can use that to reset the password. Let's see. It's saying invalid token. Sometimes it's valid, but then it's saying that this is currently not available. So this whole token thing is a rabbit hole. It doesn't work. But seeing that there's some PHP file requested here, we could actually create this PHP file and answer with a web page of our choosing. And this web page can also have JavaScript. So we basically have an XSS situation here. So now we have to think about a possible target for this XSS. We saw earlier that there's also this crossfit-club.htb. So let's go to that page as well. And here we get another web page. Wants us to sign in, but we can't really do anything. It has a sign up, but it's disabled. We could potentially enable this button and try to send this request, or just try to construct it in some other way. But if you do that, it will tell that you can't register because you're not an administrator. So that one will not work either. It is a valid way to form an XSS that will register a user, but then you have to bypass a CORS issue. So that's not really easy either. And we're going to go a completely different way here. So JavaScript, there's a lot of JavaScript here. Let's just take this app one, try to make it pretty. And this should give us some insight at least what's happening here. I mean, it's not exactly pretty, but you can see it's a Vue app. This V dash is typical for Vue apps. Let's see the title here. And how this whole app is constructed. And when I did the box the first time, I patched this so we could actually log in without having a valid login, because this Vue app is basically, it's client-side, right? So it's not really loading much after logging in. It already has the full application on your site. But there aren't any secrets in it. So you could get into the internal area, but you aren't really logged in. So as soon as it would connect to the server, you would still be logged out. But you could at least explore it, see the picture, see the UI, and so on. Here we can see some images, some descriptions, and yeah, basically get a rough idea on what this web app is actually doing. Some avatars here. Here we have the actual login. And this is where things get really interesting. There is actually sort of a chat app. And you can see that here we connect to some endpoint, and this is actually WebSocket. And there are some events emitted, like on disconnect, on user join, new user, receive global, private receive. These are events, private receive and receive global, that will be fired whenever there's a message received after connecting to the chat. And the way this website is built, the chat actually doesn't have any CORS protection that would prevent us from directly connecting to it. So if we could create a cross-site scripting payload that would connect to this chat, we would be able to get the chat messages without ever logging into the real application. And this is what we're going to try now. Actually go here. And I already created these files here. So there's this JavaScript payload. and the password reset page, which is actually being visited. So the password reset page is basically just HTML. We include one script, which is the source of socket.io, which is used by the chat. Otherwise, we wouldn't be able to connect. And we are using our own script, and we are including it from X employees because this is the domain we have redirected to our box. So it will know where to find it on our IP. And then we have this JavaScript file, and what it's doing basically is first connecting to the socket. It's a bit mirroring what we saw in the source, right? And as soon as we connect, we're sending back the ID, which is just a field on the socket, basically back to us. And we are emitting some events. Probably not all of these are even required. The idea is here to join the chat and then listen on all of these events we saw on the source. And whenever such an event occurs, we call this send to me function here, which is do an XML HTTP request back to our box. Again, using the URL and not the IP. This is important. And then as a get parameter, it will send back whatever data we gave the function, which is here, in this case, just the event in JSON format. So again, the plan of attack is the victim will go to this fake password reset page, will execute the JavaScript, which will then connect to the chat running on Crossfit Club, and it will subscribe to all the events and send back all the events to us. Let's do that. Let's start a web server here. I'm just going to use the one provided by PHP. Actually, we don't want localhost. We want on all interfaces. Then we have to start our fake DNS again. And now we should be good to go. Let's send this password reset stuff again. Let's just wait for the request now. And here a lot of stuff is going on. We can see that the bot has clicked the link. Our JavaScript file was requested, first password reset, then JavaScript, and then the chat is already starting to send back stuff to us. I can see some usernames here, Polar Bear, Paper, some others, and some global chat messages. These two were from us, and now there's some chat going on here. It's a bit tough to see here with this encoding, but let's just wait for the real one. Here we go. This chat message looks interesting. Let's copy that. Hello, David. We added a user account with password, and here we go. It's a password, and he said, hello, David. So we also have username. Let's close all of that. And let's try to SSH into the box with these credentials. And here we go. We finally got a shell on the box, and here we can read the user flag. So for root, let's look at ID, and we have an unusual group here, which is sysadmins. And whenever you have a group you don't know about, it's always good while you research it to just look for files that belong to the group. And here we found something in opt sysadmin. First, let's try if we can actually write here. And this seems to work. Okay, that's interesting. Let's look at this directory statbot. Here we have some JavaScript file. And this is actually a Node application, as we can see from the imports here. It's acquiring WebSocket file system, it locked a file. It's connecting to the chat endpoint and doing something there. But the interesting thing is that we could write in the directory there. And if we just open an interactive Node shell and do module.paths, we can see where Node is actually looking for these imports. And you can see that opt sysadmin node modules is one of the directories which doesn't exist, and we can write to this location. But even more surprisingly, also the home directory of this user. So let's say this application is executed by some other user, which is not us. If we were to place a malicious node module in the path, we should be able to execute our own code. I'm going to create a reverse shell here with resh.py, like in the other videos. Then I'm going to copy that one into the web root. Let's go to temp here. And also I'm going to open another shell here, because we will need it soon. Just start a listener here for our shell. Get that file again. All right, make it executable. Now we can deal with the real problem, which is putting a malicious node module here. And we can actually install the modules into this directory using just npm. But this box doesn't have internet access, so we have to proxy it through our box. And in Burp, to do that, you have to go in the proxy settings and then tell it to listen on all interfaces, or maybe just the external one, whatever you want, right? So then we create a node modules directory. We go into the directory, we disable strict SSL, so it doesn't give SSL errors, and then we tell it to do a proxied npm install to this directory, going through our box, right? All right, that worked. And now we can edit the index.js file inside the WS module, like that. Add our own code, which in this case just going to be require child process.exec, and then we call sh on tempx, the file we just uploaded. Save that. Let's double check that our file is actually in temp here. Okay. Let's just wait and hope that we get some hit here. There seems to be an error. Let's see. Our directory got removed, but our payload didn't get executed. Let's just try to execute it ourselves. Okay, that works. So it's not an issue with the payload. Let's try to do this whole download again here. And it should be like that. So that actually looks pretty good. I don't know why it didn't work the last time. Let's try to execute that ourselves from Node. Okay, that works as well. So the bot should be able to execute it. Let's just wait for a moment. Here we go. It just took a while. I don't know why it failed the first time. And now we are another user called John. So again, we have an unusual group, which is dev. Sysadmins we already had before. That's not so interesting. But let's look if we can find anything with this dev group. And here we already have something interesting, which is user local bin log. Let's have a look at this file, and we can see that this is actually setuid bit as root. So this will give us the privilege escalation. And just do a quick file here. It's a binary. Just run it, see what it does. And yeah, it seems to be some kind of log reader. You call the binary, you give it a path to read, and it should read it. So why don't we go for root.txt? But this is not working. So we have to actually explore what this file is even doing. Let's go to the absolute root here. Oh no, wait, let's go to temp and use ktrace to get a dump of all the syscalls. I don't know, let's go for root.txt again. Doesn't find the file. Okay, now we can do kdump and see the trace. But because we didn't execute the trace as root, we can't really see that much. So what we did when we did the box the first time was to have a local OpenBSD instance, copy the binary there, and then trace it as root there. But because then you see a lot more. But I don't have the VM anymore, and I don't want to install it. So you just have to believe me that you see more there. And actually, from the original output, if you do that on OpenBSD instance as root, you will see that there's a call to Unveil, which is like a syscall which prevents certain directories from being read. In this case, only the var directory can be read by this setuid binary. And we can easily confirm that. Let's do a ls on var here. So there are actually some files here. Let's just try to read one of those. Let's just try that one. Doesn't really matter. And yeah, we can see that this works now as we are in the root of the file system. Our absolute paths are now correct. And now we have to figure out what we want to read in the var directory to actually make an impact, right? So in OpenBSD, there's one file called etc change list. And I don't know if there's any hint to this, but maybe you know this if you are an OpenBSD guy. This change list is basically having a list of files that are to be included in a backup. Let's actually open the main page here. And here it says, it's a text file containing the names of files to be backed up and checked for modification by the system. Yeah, backup files are held in a directory var backups. So every of these files will be in var backups, which is pretty interesting considering there are some files here from the root directory, like an SSH key. So this seems pretty straightforward, right? Actually, the slashes are replaced by underscores, but other than that, we can just use this log binary and then use the path with the replacements to get the file. And we have to add a -current. That's also on the main page, I think, to get the current version of it. And here we get an SSH private key. And basically, you should be happy and would think you are done here, right? Save this as root.key. Add a new line, fix the permissions, but it's asking for a password. This is weird, right? Let's try to enter a password without giving it a key, and it's saying it wants a key. So what's the case here? We have to enumerate a bit more. And there's also a file which is relevant here, which is etc/login.conf. And if we have a close look at this file, so there's a Yubikey configured, and this Yubikey generates a one-time password you have to enter as a second factor here when using SSH to connect to the box. And we don't know that one. Let's look at this change list again. Maybe there's something with Yubikey here, but it doesn't really look like it. Can't really see any Yubikey stuff here. So basically at this point you have to look into the documentation, what files are involved if you use Yubikey and if you configure this on an OpenBSD box. And if you do that, you will see that there are basically two files involved. One of them is this one, which is var db yubikey root.uid, which is basically like a unique identifier. And there's also root.key, which is an AES key we need. And when I did the box the first time, I basically unboxed the fresh Yubikey, used these values to seed it, and then generated a password to become root. And that's a really easy way to do it. On the other hand, if you don't have that, it can be really annoying because the few scripts that are out there aren't really good, I think. And it's tricky to find them. So luckily my teammate Max wrote a script to decrypt that. And as I said, I didn't really need it in the first place, but because I had a hardware key, but most people don't have one, so I'm going to share that here as well. And here we go, that's the script. I can't really explain that Max wrote that. And honestly, I don't want to dive too deep into this Yubikey stuff anyway. If you're interested in that, just throw a DM to Max or something. Or probably you can also read it up in the documentation, right? So basically there is a way to use that to create the key without having an hardware key, but otherwise the really easy way is just to seed your hardware key with it. And if we execute that, we get the one-time password. And if we now SSH and enter the password, we are in, we are root, and we can read the root flag finally. One thing to keep in mind here is that there's also a counter involved. So you can't use that root password again. It only works one time. If you want to use it again, you have to include the counter here in the calculation. And Bex had also written a script for that. If you're interested in that, just ask him on the WoundDev Discord or something. So thank you for watching. I know this was a bit hard to follow, and it was also a really difficult video to make because a lot of stuff is really finicky and doesn't work all the time. But overall, it's a really cool box, I think. And yeah, see you next week.